You guys know when you're professionals at doing formulas, when you guys don't even know why something gets the answer, but you can get the answer. All right, so take a look at this. I've got flux lines through a circular base. A radius r stands upright to the vertical. The electric field travels upwards in the vertical direction. Electric field flux lines will be going this way. It says vertical. Show that the flux through the cone surface, not counting the base, is given by this. So we're going to start talking about a couple things that are going to pop out of this. One, I take a look at this and go, crud, how am I going to do that? You've got angles, right? And you're going to have to figure out the surface area at the top of a cone. Or you realize however many lines are going to the top of the cone came in through the bottom of the cone, right? So therefore, these must be equal. And therefore, I'm just going to go EA, sine of 90 degrees if I want to put that tacklet on, right, as flux. And therefore, my electric field is, oh, they didn't tell us, E, okay? E, the area is going to be pi r squared because that's the area of the circle on the bottom, and the sine of 90, and we're done, okay? You don't have to worry about the top. Yes, sir?
So had the electric field been applied horizontally,
we'd have all sorts of problems.
Why couldn't you just do 1/2 base times height? Oh,
you could use a triangle. You could do that. It would work.
But isn't it slanted? So
you just need to know what the shape is that it's passing through. So if you draw a silhouette of the picture, whatever's passing through, that's what it's going to be.
And it's just passing through a triangle.
Right. So you're legit. That's exactly what you could do. Okay. Now, one other thing, and I need to start getting this right now because we're going to start playing this game soon anyways. Why does it say neglecting the bottom? I mean, we use the bottom to calculate it. Why does it say neglecting the bottom? Because we're going to do something very strange in a little bit. Lines that go into a shape are negative. Lines that go out are positive. So the net flux through the shape is going to eventually be what? 0, right? Because we got just many lines going in as coming out. Does that make sense? So just as I'm just poking at that a little bit, we'll pull back from that and do some more problems, and we'll come back to that discussion again. The flux lines, the net flux coming through this thing would be 0 if I count the bottom as a surface, because the number coming in and the number going out is the same. Agreed? Trying to understand that a little bit? All right, try the butterfly net problem. In light of number 2, it should be much easier than when you first look at it. Oh, wait, you need the discussion I just had. Yes, try number 3.
Do we have to count arrows?
That's what we're doing by doing this process, theoretically. But we're not really doing that anymore. I've got a butterfly net, and I've got this whatever droop. I'm going to make some sort of weird shape. It doesn't really matter. Okay, I've got electric field lines, right? My electric field lines are, can you stop playing with components back there? I've got electric field lines going this way, right? All along here. Now, this electric field line goes like this one goes like this one goes like this, right? Enrico.
Yeah.
It is a stipulation of the people in the front, including Mr. Bernard, that it's just the area of the circle that matters. Is he right or wrong?
The diagram only has the electric field lines going.
The electric fields are permeating space, right? There's lots of them coming through.
Okay.
Right? And we're counting how many lines. So that's, does that make sense now? Okay. So he says only the circle will matter. Is he right? Then why? Or why not?
I mean, you have the bit that's not like...
Right. So we would say that, just in my stupid simplified drawing, right, I've got 3 lines passing through the surface, right? So I got 3 ones entering, so I should have flux of 3. If I just use his idea, I got 2. But what happens to the one that does not go through the opening? Where does it have to go through?
The net.
The net, which means it's going in and out.
So it's canceled out.
So that cancels that one out. And so we say that one does not count, right? And so the only thing we'd have to worry about is the ones that actually escaped through the hole.
Oh, they're escaping?
Right.
It's neato.
So the flux lines that hit the outside of the net, only the ones that go through the hole at the entrance would count, right? And so I'm allowed to do exactly what he says, which is do what? EA equals flux. So my flux is going to be whatever the E and the A are.
E is just E.
E just E, and I believe this is pi little a squared. So that would be the answer. How many flux lines would be traveling through there? Got it?
Mr. Rizzi.
Yes, sir.
So, but that's like, even then though, it's not like a truly two-dimensional shape. I mean,
True.
the strings of the net are still three-dimensional.
Right.
If you had like an object that was actually two-dimensional, how would that change it?
Wouldn't change it at all.
Flux lines.
We're treating it like two-dimensional. We're not worrying about the one that might somehow skim this edge here and not actually go inside because it would have width. We're pretending that such things don't happen because I don't want to think about it too hard. Is that going in or is that going out? Let's not do that. Make sense? So we are going to treat everything as a super skinny two-dimensional object. Ultimately, that's where we're going. We're going to make two-dimensional objects that are infinitesimally skinny to do our problems.
But does that even happen, like in real life?
In real life, it doesn't matter. Are flux lines a real thing?
Why are we doing
On
this?
the AP test,
Like we're like
on the
Potions
AP
class.
test, it's Potions class. And the AP test, they may ask you what the flux is. And I always wince when I hear that question because there's no such thing as, there literally is nothing. The flux is a made-up thing. It is. It's flat made up. It's even more made up than electric fields, which, by the way, is made up to begin with. So we're using flux lines to determine electric fields so we can find something real, which is, you can understand why Ampere in that crowd thought that Faraday was making crud up. Like he was using all these weird things to get these answers. But if you get this, it's a heck of a tool. It's a really nice tool. But we're only halfway through the tool. I promise you. We got another half to go.
But what
Okay.
you're saying is this is about as useful and applicable as me reading Star Trek fan fiction.
No, Star Trek fan fiction might get something useful from it.
Okay.
What I'm saying is until I get to the second part of this, this should feel like I'm calculating the number of lines I would draw on a piece of paper when I draw to represent the electric field. Huh, that's interesting. Don't know why I'm doing that. And now he's got a rule about going in and going out of shapes and how many flux lines does that count as? Because it went in one side, now it's coming back out the same, like it went back out of the shape, so I can't count that. He's making up these rules about how to count these lines.
So what are we learning right now that isn't imaginary?
We are learning a mathematical tool, which is incredibly powerful to figure out a way to visualize how an electric field actually permeates the space around it, and how to actually calculate the force, the voltage, and those things which are useful, real things. In fact, they are the best tool for doing these things. But in order to do that, you have to go through this strange land of flux. And it's so important to go through the land of flux that you will find in the AP test, they'll ask, what is a flux? And you got to come up with an answer. Think about the units. The units are Newton meters squared per coulomb. What the heck are we talking about even? That's the number of lines traveling through that space.
So we're talking about.
But bear with me. I'm only halfway through.
Okay.
When I get to the other end of this, we are actually going to delete the flux completely out of it. And all of a sudden, we're going to have an equation that actually has everything on every side, has a utility to it that you recognize. But in order to get there in a way that doesn't, let's just use the magic formula cone, we're going to have to go through this flux idea. And it is good. This is legit. This is Faraday at his finest. Taking something that everybody else said was too hard for normal people to do and giving us a tool that eventually when we get done with it is like so easy. You're like, wait, we just went through this huge hairy thing, all my hair is falling on my head, and this is the answer? Cool, let me use that a lot. Okay, so we're going there. We're not there yet. Okay, 12.6 you should be able to handle now, so get on 12.6.
Good thing that was all recorded.
Yeah, well, no, these discussions about